Module 4 CAMS. We are in the numerical problems. So numerical problem number 2 to draw the cam profile. So this is the question. A cam with 3 centimeters minimum radius is rotating at clockwise at a uniform speed of 1200 rpm and has a to give motion to knife edge follower as defined below. Follower to move outward to 3 centimeter during 120 degree of cam rotation with SHM. Dwell for next 60 degree. Follower to return to its starting position during next 90 degree with UARM. Dwell for remaining period. Draw the cam profile when axis of the follower is offset to right by 1 centimeter. So first he has mentioned about minimum radius, that is 3 centimeter, which is required to draw the cam profile. Then he has mentioned the direction. So those are required to draw the cam profile. Next, A, B, C, D are the 4 points which describes the motion of the knife edge follower. So follower type is knife edge follower. Follower to move outward 3 centimeter with SHM for a 120 degree, next 60 degree dwell. Then the follower is returning to the starting position with UARM for 90 degree, dwell for remaining period. Last part, draw the cam profile when the axis of the follower is offset to right by 1 centimeter. Okay, so this is a offset type of cam where the offset distance is 1 centimeter mentioned in the problem. So we'll start drawing. As I already said, there are two parts in a when you draw a cam profile. First one is drawing the displacement diagram. Next is drawing the cam profile. So we'll see those steps of drawing the profile. So there is no need of a graph sheet to draw this. You can draw this just in the plain sheet. Okay, so first we will draw the displacement diagram. Okay, so displacement diagram, what is required to draw the displacement diagram? So displacement diagram, as already told in the introduction part, it is nothing but the diagram which indicates movement of the follower. So there are two axes, x-axis, y-axis. X-axis defines the degree of movement. Okay, what is the rotation, degree of rotation cam has traced? How much is, what is the rotation? It is complete 360 degree rotation. Okay, so complete 360 degree. So we have that will come in the x-axis, whereas in the y-axis it will be the displacement or the other thing but the stroke. Okay, how much movement has taken place? Here the maximum movement is 3 centimeter. Okay, follower can move up to 3 centimeter, that is our stroke length. Clear? So draw this box first which defines the x-axis and y-axis. Now x-axis 3 sorry, y-axis 3 centimeter you can draw easily, that will fit in your book. Whereas the degree, can you draw a degree? It is very difficult. We can't directly draw the degree here in y-axis, the x-axis. So we need to convert that degree in terms of linear scale, that is centimeter or mm. Okay, so first draw the, so first write the scale. So write the scale. So here the scale will be taken as 20 degree will be equal to 1 centimeter. So if you draw 1 centimeter, that is equal to 20 degrees. So always write the scale first. So draw this in your book. Scale 1 centimeter is 20 degree. So follow the scale now. So once you understand, you can take your own scale and draw it. Okay, 1 centimeter is 20 degrees. So keep this side, so it should be there in the top, you know what is the position of the scale. Then draw the x and y axis. So first the 30 degree y axis, which defines the stroke length. Then y axis you have drawn. X axis, so the 360 is converted to the scale, so 360 will be 180 mm or 18 centimeter. Okay, so that is drawn. So this type of box you have to prepare. It will be a rectangular box, x axis with the degree representation, y axis will be the stroke representation. Okay, so now after drawing this, we have to divide this box into different parts. So the parts will be the indication of the angles mentioned in the problem. So in the problem first part, the curve, the outward movement taking place at 120 degree, then dwell for 60 degree, then again return at 90 degree, then dwell for remaining 90 degree. So that angles should be marked on this y-axis. So division has to be done. So that division I'm doing here now. So first is 120 degree. So according to the scale, what is 120 degree? It will be 6 centimeters. So mark that line at a distance of 6 centimeter, but don't write 6 centimeter, write the angle. Okay, so next is 60 degree. According to the scale, 60 means 3 centimeters or 30 mm, that has to be marked. Next one is 90 degree, so this is 60 degree. Then 90 degree, according to the question, the C, the inward movement or the returning to the starting point, it is at 90 degree. Write all those angles. Okay, first is 120, next 60 and 90. Okay, angles. So this is how you have to divide the box into different parts. So angles are given in the question. According to that, you have to divide. Now first one is 120 degree, so we will just concentrate on that now. The first one is here SHM. So steps when SHM type of motion E. So whichever section has SHM, first divide that into minimum of 6 parts. You can divide into more number of parts. So here 120 degree section has SHM type of motion. So first divide that into 6 equal parts. That is the first step whenever you have SHM type of motion. So name that accordingly 1, 2, 3, 4. You can start from 0 also. So first one is 1, next 2, next 3, 4, 5 and 6. Okay, 6. You can divide into 8 parts, 10, 12. There is no restriction for that. So if you divide more number of parts, you will get more accurate profile. That's it. So make a habit of dividing into minimum of 6 parts. Second step is draw a semicircle at any one of the side of the box. Okay, you can draw on this side or on this side. Okay, on any one of the side, draw a semicircle from the center point. Okay, so 3 centimeter is the height here, so 1.5 will be the radius. So draw a semicircle. So once you draw the semicircle, divide that semicircle also into same number of parts. So here you are divided into 6 parts. So same number of parts you divide this semicircle also. Okay, so 6 parts it has to be divided, equal 6 parts. So 180 by 6, 30 degree each. Okay, so it will be equal number of parts. So draw the lines from respective points. First I will name that ABCD, that will make you clear. So first point, name it as alphabets. Okay, A, then B, C, D, E, and last one F. If you have more points, go on naming with the alphabets. So it looks like this. So from A, draw a line to 1, from B to 2, C to 3, D to 4, E to 5, and last F to 6. It's already there. Okay, now this intersection point, what you get, name that as 1 dash, 2 dash. Okay, alphabet, the numbers with the dash. So this intersection point, it is very important for us. 1 dash, 2 dash, 3, 4, 5, and finally 6. So these intersection points are very important. Now starting from 0, join all these intersection points, not with a scale, just freehand joining. Join all these points. So this is the displacement curve for the first movement, that is the upward movement of the follower. So we have completed that 120 degree. So next is that part is over. Second is dwell for next 60 degree. So it is just constant. So now curve has reached till point 6 dash. So there you just draw a straight line for that particular duration. For the 60 degree, you draw a straight line. I'm just indicating with the red color so that you can differentiate the curves. Sorry. So the 60 degree we have completed. Next we will go to the 90 degree part. So they have told that it is coming back to the starting point with a 90 degree duration with UARM. So when you have UARM, first step in UARM is similar to SHM. Divide the section into equal parts, that is 6 parts, equal 6 parts. Okay, how you are divided in SHM, similar way divide that here also. That extra lines, remove it, not required. Only inside the box you have to draw a line. So remember, it should be equal 6 parts, not random 6 parts. So while numbering here, it should be in the return order because the curve has already reached sixth point. Okay, so we have to name that in the reverse order, not 1 2 3. It will be 6 5 4 3 2 1. Okay, so first point will be 6 here, next 5, because it is returning. So curve is already at the topmost position, the follower at the topmost position, so it has to come back. So 2 1, last one is 0. You can write 0 at the first point. So next step is, in this 6 lines, select the middle one. Now out of this middle line is third line. Okay, so 1 2 3, 1 2 3 parts on the either side. Select the middle line, divide this middle line into same, how much you are divided here, 6 parts you are divided. Divide this line, the middle line, also into 6 parts. Okay, equal 6 parts in the upward direction. So in this way you have to divide. Small line you can draw, or the one point, it just indicates the division of this line. Okay, equal 6 parts. So if you divide 8 parts, this is also you have to divide into 8 parts. Now only 6 parts are there, so divide that into 6 parts. Not end up writing any dimension. Okay, so divide like this into 6 parts. Small line is enough. So these points what you have marked here, name it with the alphabets A B C D. Okay, from bottom A B C D, name it in that way. So first point A, B, third one is C, D, E, and F. Okay, now after drawing this, so again you have to divide into two parts, top three parts, bottom three parts. So first point, whichever point, the starting point or end point, whichever is nearest to these 3 points, join those 3 points to starting and end point. First three will be joined to the end point, last three will be joined to the starting point. So like this, first point to ABC, last 3 points to DEF, in this way. So line from A, where it cuts the line 1, that will be 1 dash for us. Okay, you can see here there is a line from A, it is intersecting on the line 1, so this point. Okay, that is our intersection point, so name that as 1 dash. So like this. So this intersection point, line from A and 1, so that is 1. Now line from B and second line, so this is the point, so that is 2 dash. Next 3 and C, this is the intersection point, 3 dash. 4 and D, this is the intersection point, 4 dash. 5 and E, this is the intersection point, so 5 dash. And last 6 and F, this is the intersection point. So this way you have to name. Now join all these points, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, whatever the points you have marked, join all that with just a freehand curve, not with the scale. So this is the return curve. The curve is coming back to the home position. The follower is coming back to the home position. So this way you have to join all that intersection point. This completes the second type of motion, that is UARM, the return stroke. Okay, so last it is dwell, so just continue the line constant. So this is how the displacement diagram is drawn. Okay, so now this curve is very important. So any problem, first you have to draw the displacement diagram, so that is very important here. So this is how a displacement diagram looks. Next we will see the second part of the problem, that is drawing the cam profile. So we need this displacement diagram to draw the cam profile. So there is second part of the problem, that is to draw the cam profile as given in the question. First we will draw the base circle. The radius given is 3 centimeter. So draw a circle of 3 centimeter radius. So our problem is offset. So first step is same as the radial follower. Second step, we have to see what is the offset distance given. So your offset distance given in the question is 1 centimeter, if you see that. So from second step is from same center, draw a circle of radius equal to the distance given. So here 1 centimeter is given. So draw a circle of radius 1 centimeter at the same center. So it looks like this. Next step, from the end of this circle, that means you have to draw a tangent to this circle. So from the side given in the question he is telling that offset is right 1 centimeter. So towards the right side, so there is this side. From here draw a line tangent to this circle. That offset inner circle is called offset circle. From the offset circle draw up to the base circle. So like this. So when it's offset, this is the extra step you have to do. In radial, you had drawn directly from the center, but here a tangent on the offset circle. Then place the knife edge follower at the tip of this line. So that is your reference line. So once you draw this, join this end point to the center of the circle. So this inclined line is our reference to divide the circle into different angles. Angles are what is the display, the division what you have done in the displacement diagram. Same thing here with respect to this. The rule remains the same. What direction is given in the question, we have to move in the opposite direction to divide the circles into different angles. So given in the problem is clockwise, so we have to move in anti-clockwise direction. Okay, anti-clockwise direction to divide the angle. So first angle is 120 degrees. So with respect to this angle, this line, so angle between this line and this line, it's 120. Okay, second angle 60 degree. So this line, next line is our reference. So 60 degree. So angle between this line and this line is to be kept 60 degree. 60 degree between these two lines. Next angle is 90 degree. So continue in the same way. From here, draw a line perpendicular, that means 90 degree. So angle between this line that should be 90. Okay, like this, 90 degree. So divide the angles in this manner. Okay. Next step is bit different compared to the radial follower. Here you have to, there you had divided the section into six parts, how you done in the displacement diagram. But here you have to just mark on the circumference of the circle, not drawing, not dividing the section, the part into six directly, but you have to mark on the circumference. Okay, so this circumference you have to divide into six parts. Okay, just you have to draw arc on this circumference. So for that, first I will do line, get the angle. Okay, so from here so draw a small arc, then after that no need of this line. Okay, so continue this arc throughout. So divide this into equal six parts. Okay, so like this, just mark on the circumference of the circle and name these points. 1, this is 2, 3, 4, 5, and 6, like this. Okay, same way 60-degree section we didn't divide in the displacement diagram, so don't divide here. Here in the 90-degree section, divide again that into six parts each. Next 90-degree section also divide into six equal parts. Okay, then name in the similar manner. How you have named here. 1, 2, 3, 4, 5. Sorry, sorry, the numbering should be in the reverse order. 6, 5, 4, 3, 2, 1. How you did in the previous, in the radial type of problem. Okay, next, from all these six points, you have to draw a tangent to the offset circle. Like from this point, so from points what you have marked on the circumference, from all these points, you have to draw a tangent line to the offset circle. So from this point, first tangent line. So see that it should be proper tangent to the offset circle. So next second point, the same way, draw a line. See here the point what you have marked. From there, offset line. Sorry, yeah, tangent line. And from third point, the same way. the tangent. See that it should be a proper tangent. Use your scale, keep it in the straight line so that you can make out the tangent line. Okay. If you just keep the scale from the point to the circumference, the surface of the circle, you can draw the tangent line very easily. So from all the 6 points, you have to draw a tangent line. Right. So once that section is over, go for the 90-degree section. Again, for all the 6 points, from all the 6 points, draw a tangent line. So 6.5, 4, 3, 2, one. Last 0. End at 0. Don't stop at 1 always. Okay, you have to go reach till the last point, 0 point. Okay, now, so after drawing the tangent line, we will go back again to the displacement diagram. How you have extended the lines from the displacement diagram in the radial follower, same way measure that 1 dash line, extend this tangent line, same way the same tangent line has to be extended. Don't incline it to any angle, just the tangent line has to be extended in the straight line. So see, 2.222 dash distance is to 7.5, so from point 2 extend the 7.5 straight line. See that it is a straight line. Next 15 is the distance between 3 dash, so from point 3 draw a line of 15 length. Next 4 dash distance in the displacement diagram is 22.5. Add that to this end point, 22.5. See, it should be a straight line. The same tangent line is extended. Next 5 dash, it's 27.99. Extend here, that's a tangent line. Next 6 dash is 30. See that tangent line is extended, not the other line. Again, next section, the 90-degree section, in that 6th point, see that tangent line is extended, 30. Next 28.33 between 5 dash. So join that 28.33 to here. Extend the tangent line. Next go for 4 dash. The length is 28.33. 23.33. Join that 23.33. Same. The tangent line is extended. So this is in the offset type of problem. The tangent line has to be drawn and the same tangent line has to be extended. Next 3 dash. 2 dash, length is 6.67. Measure with the scale or compass. Do in the same way. Okay, 6.67 is extended. Next, last one, 1 dash 1.67. So that one from point 1, add 167. Same, the tangent line is extended. Okay, now name all those endpoints: 1 dash, 2 dash, 3 dash, all the endpoints. You go on naming. So first one is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Again the same thing in the other side: 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, and 1 dash. The last step, drawing the cam profile. Freehand curve you have to draw from the first 0 point. Go on joining these endpoints: 1 dash, 2 dash, 3 dash, sorry, 3 dash, 4 dash, 5 dash, 6 dash. Again back in the other section: 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and back to the 0 point. You can write the 0 at the end point. So this completes the profile. So I'll highlight that with the red color. So this is the cam profile for the offset follower.